All of the parts arrived, and so today I'm going to assemble the first prototype of my smart home sensors. This is the smart home sensor that is based on the ESP32 with power over Ethernet and with a lot of sensors. Let's see if this works. First, a big thank you to PCBWay, link to their website in the description. They sent me these PCBs for free. I'm not sure what I'm going to do with that one. So I got PCBs, they're white PCBs, and a stencil mask for applying the solder paste. About a year ago I tried to build my own solder mask out of paper by using a laser cutter, and it kind of worked, but of course the metal version is superior. Now with new designs that I never tried, like this one, usually I try to assemble it step by step, so part after part, and test the components and test if a certain circuit works. So in this case, for example, I would really love to start with the power over Ethernet circuit and then test this before I place all of the other parts. I could make sure that everything works and it doesn't produce too much voltage for the chips and stuff like that. But in this case, the problem is most of the stuff on this board is surface mounted and super tiny. I will go with the reflow soldering process, and so I have to put on all of my components at once. So the first thing that I'm going to do is apply the solder paste, and then I will place all of the surface mounted components. I will not connect all of the sensors because some of them are quite expensive, and then I will power on the board with a current limit and with my thermal camera in my hand. That's my plan. So let's see how it works out. Let's open this. So, first impression of PCBWay's PCBs. I ordered 5 of them and I actually got 6. PCB itself looks great. The next step is the solder paste. That looks very nice. Unlike my own solder mask, it perfectly fits the PCB. Here's a trick on how to apply this solder mask. There is a tool where you can mount the stencil and you can mount the PCB, and then they fit perfectly on top. But I don't have this tool, so I will do something else. And in case you're wondering, the solder paste consists of tiny drops of tin swimming in flux. This looks perfect. Usually it's good to do more than one board, but in this case I have no idea if it works. By the way, does someone of you know how to clean this in a good way? Very tricky to clean. This looks good. And smells good. The placement of the solder paste looks perfect. Let me show it to you. So let's start the placement. I have my KiCad file open. I have my footprints. I will sort them by values. I will also open my bill of materials. 3.8, U5, U5. All right. This is going to take a while. Actually, you don't push it, you just place it. But yeah, why not? Let's put all of this here. I just put all my chips on the table. That one was bad. The speaker doesn't look too good, but everything else looks great. A lot of parts are missing, but this is enough to test the basic functionality. We will also need this. The last thing is this connector right here. We are going to inject some voltage into this thing right here, 15 to 48 volts. Let's start with, I don't know, 24 volts is a great number. The current should be limited quite heavily. I would say we go with maybe 50 milliamps. Let's see what happens. Voltage is on. Okay. Okay, nothing horrible happened. We have 6 milliamps and something's heating up here, but not much. Ground of my multimeter is now permanently connected, and I can now measure, for example, right here I have 24 volts, which is exactly what I expect. The output of this DC-DC converter is 5 volts. So right here we should see 5 volts, but we don't. Enable. Ooh, okay, yeah. I guess it needs to be enabled. This thing is very hard to trick. Enable pin. Connect to low of the chip. Floating is enabled. Okay, off the chip. So if it's low, then the chip is off. So the problem is the power good output would be high if the power is good, but it is actually actively pulled low if it's not good. And right now it's not good. If I now forcefully pull it high, then the transistor inside of this chip will just die. Yeah, I have one idea. We can remove this inductor and then I can test the rest of the circuit, because if I just connect 5 volts, it's not good for this DC-DC. Set this one to 5 volts and the current to, let's say, 500 milliamps. Maybe not even 500, maybe 300 milliamps. On who? That power consumption was too high. Let's try it again. Whoa, okay. So the problem is this chip right here. This chip. Boom. That one heats up like crazy. There might be something wrong with that. I think I found out what the issue is. I connected the negative supply voltage to 3.3 volts and the positive supply voltage to ground. So the reason is, when I constructed the schematic, I flipped the symbol and it also flipped the supply voltage, of course. Yeah, who would have thought that? So looking into the pinout, it looks like this. No. No idea if this works, but let's see. Turn it on. Maybe it's broken, but at least it doesn't get hot anymore. Now I can use web.esphome.io to connect to my device. I will connect ground to ground, obviously, TXT to RXT, and RXT to TXT. So the sender needs to be connected to the receiver, and the other sender needs to be connected to this receiver. We need to put this ESP into the right state. GPIO 0 must be low to enter flashing mode. I will use 2 tweezers. The first tweezer will connect GPIO 0 to ground. And now I will also connect ESP-EN to GPIO 0 at the same time. And now release. And now ESP32 should be in the correct mode. Connect. Prepare for first use. Install. So this is great. We now know that ESP32 works. It is able to communicate using the serial connection. What we don't know is if Ethernet works. We have no clue. And we also have no clue if the step-down converter works, because now I inject 5 volts directly. Because of this power-on circuit, I want to use Ethernet. And so we need to prepare something different. How it works is, this is my configuration file, and based on this file, it compiles a firmware. Which is crazy. You don't have to write a single line of code, you just write this configuration file. We'll do it like this. And now let's try again. Yeah, the port is busy because it's connected to Chrome. So let's quit Chrome and try again. Okay. Great. So the next step is to connect Ethernet. I will put this inductor back in. We also need the Ethernet connector. Unplug this thing. So I feel like I did everything in my power to make sure that this PCB works. Let's connect it to my Unify switch. And that one is very expensive, so a bit risky. But let's see what happens. Wow, the LED is blinking. Nothing gets hot, I can ping it. It's so crazy. So the next step is I will add all of the components to this PCB and then increase the parts inside of the configuration and see if everything works as it should. So please like and subscribe to this channel to not miss out on any future videos. Thank you for watching. See you in the next video.